Now, the Gemma 3N model was released recently by Google, and it is the first fully multimodal model designed to run locally on your hardware or on edge device. Now, if you scroll down to multimodal by design, you can see over here it says Gemma 3N natively supports image, audio, video, text inputs, and also text outputs. Basically, like most models. Now, in today's test, I won't be running it locally due to my hardware constraints, but I will take you through the local setup steps, even if we'll be more focused on building a PyQt6 GUI that can interact with all Gemini 3 modalities that we actually talked about here using the Gemini CLI. And the PyQt6 GUI will be connected to a fast API endpoint, which I set up earlier on my cloud server, and it's currently running the Gemma 3N model. So that's how we'll be running all our tests basically. But if you do have a beefy GPU or reasonable sized VRAM and all that, you can actually run this locally and just switch to your local endpoint. So it's just no difference. It's really that simple. Before we dive into our IDE, something I forgot to mention is the fact that Gemma 3N models are available in two sizes based on effective parameters, E2B and E4B. I think that's what the E actually stands for in their name. Anyways, while their raw parameter count is 5B and 8B respectively. So architectural innovations allow them to run with a memory footprint comparable to traditional 2B and 4B models, or pretty much as little as 2 gig of memory for the 2B and 3 gig of memory for the E4B. So you can just keep that in mind. Now, if you want to actually set this up locally, if you want to download the model weights, you can head over to any of these platforms. You could download either the E2B or the E4B model weight from there. And as you can see here, they have the instruct fine-tune models, hence the IT. You could just pull the model weights, or you can actually download it manually and keep it in your local directory or your project directory. Depends on where you want to actually set this up. So you can just click on the download icons and you can download the model weight. It's really that simple. Or you can use the Hugging Face Hub CLI to download the model. And then you can come down here and just copy this code and you should be good to go. Anyways, something to take note of is for the quantized versions, need to sure they actually allow all the modalities. I think it's mostly just image and text. That's for Llama and LM Studio. That's something else to actually keep in mind. I'm not sure LM Studio actually supports audio, so just keep that in mind if you want to actually set this up locally. Anyways, let's dive into our IDE where we will create the GUI using the Gemini CLI agent, and let's see what happens. So we have our project directory opened, and the two files we do have here are the .env and gemini.md file. The gemini.md file basically contains our project description, which we'll pass on to the Gemini CLI agent. So all the description actually contains are the instructions for it to follow application structure, Flash UI with proper icons using Qt awesome package. It already knows it's Python. Anyways, create a PyQt6 main window with 4 sidebars, text, image, audio, video. Each tab should have appropriate input controls and just one output display area for all. Include a settings panel for API configuration, add proper error handling and user feedback, set up virtual environment using venv before requirements installation. So these are the things it should actually follow. So the design choice, give the UI a dark theme with a background opacity level of 70%, background RGB color of this, and text RGB color of that. Also, after recording audio, it should preview at the top area in the audio widget and can be listened to if need be. The audio widget doesn't need transcribe. That's a simple error. Anyways, since Gemma 3N supports all modalities, it only needs a response section like other widgets. Make sure once recording starts, there is a stop, pause recording, but use icons for better UX. So okay, it doesn't need transcription since Gemma supports all modalities. So technical specification, PyQt6 for GUI, Google AI Python SDK. So hold on a second, I made some changes to the technical specifications. So this is Austin from the future speaking, and under the API integration, it's no longer going to be connecting to the AI Studio API endpoint. It's just going to be connecting to my cloud server, basically, like I said earlier. And here is where you pass in your IP address. If you're running it locally, if you have a beefy GPU, like I said, you can actually just pass in your localhost IP address here and then the ports. So Gemini CLI agent could just take it from there. But these are the endpoints I actually used health to just check if it actually works, and then this inference / text, image, video, audio. So that's what it actually supports. And I also removed the VR AI Studio from this line. So let's continue with the video. This is package name, and also the model Gemma 3 and the 4B parameter via AI Studio. And also we have the code structure. Basically, we're telling the Gemini CLI agent how to structure our project. So it should actually have no problem setting this up. It might run into a lot of problems finishing it and making it actually usable. But let's just begin. So this is the prompt I'm going to pass to the model. As you can see, it's using the Gemini MD file. So I'll just hit always allow until it's done, and once it's done, we'll be back. So I want it to actually debug it, so let's tell it to. So after making a lot of tweaks, it's finally done, and we can set up the PyQt6 GUI right now. But let's take a look at the folder structure. As you can see, we have the src directory, which we stated here. We also have main.py. It's actually moved main.py to the root directory here, but I don't know why it did that. Anyways, we do have the UI directory. We also have the core directory, including the audio tab, image tab. We also have the main window, text tab, video tab. Also, we have the utils, helpers, validators. I think these files are empty, but the core logic is actually here in the core directory where we have the API client. I can't open that because it's actually pointing to my cloud server static IP address. So I also have the config, basically the file handler, the worker. So we're going to be running main.py, and it's in our root directory. Now let's take a look at the code base that's currently running on our cloud server. And as you can see, I used the Gemini CLI agent to set this up, and it was pretty straightforward. I gave it all the instructions it actually needed. Over here we have our API endpoints, which it actually set up. In inference, okay, we have the text, image, video, and audio. So it's pretty straightforward, and we also have health. They can all be found here in the routes directory under the app folder, as you can see. We also have the logs to just log everything that actually happens in case we get an error, because I did want Gemini CLI agent to be able to evaluate and fix it on its own. But here also I made a lot of tweaks to get this set up. So the model directory contains the cached or caged model weights. Basically, I just set it to use this particular directory as its cache directory or catch directory, however that's actually pronounced, and I set it to local files only, so it's really simple. Let's head over to the model config. You can see it here. As you can see, local files only, and I also set the catch directly to model. So it's pretty straightforward. And since it's a gated model, you would need your Hugging Face API key or access token. You will pass it into the model and also the processor. So that's something you would need to actually set up. It's pretty straightforward. I have a .env file here in the root directory, and that's what we're actually getting here. So a quick note, for the model, I use the auto model for image text to text. It's quite different from what they actually use in their example on the official Hugging Face page. Now let's head over there so I can show you what I'm talking about. And over here, they're setting up the model by calling the Gemma 3 for conditional generation class. So currently, as at the time of the recording of this video, this doesn't actually work for audio. You can actually pass images, but you cannot actually pass in audio currently. Maybe that would actually change in the future. I do not know. But for this test, I did switch the model class to something else. So I switched it to the auto model for image text to text. So that's what actually works for me. So enough of the ranting. Let's just start up the fast API server and get on with our test. So to actually start the fast API server, this is the file we're going to be running, api.py, as you can see. So we're running it on this particular port. And let's head over to our local code base to start our PyQt6 GUI. To start up the PyQt6 GUI, we'll have to run main.py. Since it's in our root directory, all we have to do is run this command. So I'm placing it over the cloud server because I want to see what's going on in the console. Now we'll try out the text. Let's send a message. So once we actually get a response, we should see something pop up here. And as you can see, our request was successful. We got 200 success code and we got okay. So hi, how can I help you today? I'm ready for anything, questions, stories, brainstorming, or just a friendly chat. Let me know what's on your mind. Now let's head over to the audio tab. So once we click on the record button, it should start recording our audio. Hi there, can you tell me what your name is? So this button right here is to pause and resume. So once I'm done collecting my thoughts, I can just resume it. Can you also tell me who created you? So as you can see, we have 6 seconds of audio. Let's play it. Hi there, can you tell me what your name is? Can you also tell me who created you? Now we can actually send this audio over to Gemma 3N. We do not need to add in a text. And so we got a response. I am Gemma, a large language model trained by Google DeepMind. I am an open weight AI assistant widely available to the public. My creators are the Gemma team. Really cool. Now we can also ask you to transcribe. So you can see, hi there, can you tell me what your name is? Can you also tell me who created you? It sounds like what I actually said. Let's play it. Hi there, can you tell me what your name is? Can you also tell me who created you? You just used the wrong word. It said hi there instead of hi there. So that's just the only error it made. And maybe that's because of how I pronounced it in the audio recording. Anyways, for our next test, I'm going to upload an audio file. So it's currently in my project directory. It's called angry.wave. We can play it so you could hear what it actually sounds like.
I am so sick of your this is the job excuse.
Well, fine. You don't want me to work so much? Great. After dinner, we'll put your resume together and you go get a job.
So I'm going to leave this empty and let's send it over to Gemma 3N. So he did a pretty decent job when it comes to breaking it down. As you can see, I am so sick of your this is the job excuse. Pretty good. Fine. Don't want me to work so much. Great. Blah blah blah. But here it says the speaker is frustrated, which is actually accurate with the other person's excuses and is threatening to fire them. But in that particular scene they're not actually threatening to fire them, but the main thing is this is a small snippet of audio, so it's definitely not going to get the full context. So the main thing is, can it actually understand what's going on? And over here it says this whatever this is likely amplifies the speaker's anger and finality, which is really accurate. So it's pretty impressive, especially as it assessed the speaker's emotions correctly from the audio file, and it also transcribed some parts of the audio and also broke it down. That's really cool to see. It's not bad. It's not bad at all. And so we'll head over to our image tab for the next tests. And this test would have to do with OCR and also image understanding. So we'll see if it can actually extract the text from images and then use it as context in some cases. Anyways, let's just dive in. So we're back to our PyQt6 GUI code base, and these are the images we're going to be trying out. Because you have this. So I added this image to this test so we could actually find out if they labeled celebrities data in their training data sets. So we'll see what actually happens. And the next image is this, still OCR and also image understanding. Then this, and finally this. We'll just use either one of them. So we're going to begin with this image, and for this particular test, we're going to be asking it which of these models actually has the largest context window. So as you can see, Gemini has 128K to 1 million. I don't think any other one has that, so it should be the winner of this particular test, but let's pass in the image and see what happens. And let's send it. As you can see, it actually did a pretty decent job. It said, based on the image, Gemini 1.5 has the largest context window with 128K to 1M, and that's pretty good. And it also separated the Gemma from the Gemini 1.5. If we head back here, as you can see, Gemma has its own, which is 8K. So it's not bad at all. It actually did a pretty decent job with this. Okay, on to our next question, and this time we're going to be asking it about Gemini 1.5 release date, and it's right here. What is Gemini 1.5 release date in this image? Okay, according to the image, Gemini 1.5 release date is 24 to 15. That's 15th of February 2024. Let's check it out. Okay, it's accurate. That's really cool. So for our next test, we're going to be taking a look at another chart. Let's see, where is it? So this is a very old benchmark comparison table, and we're going to ask Gemma 3N which of them is actually the best coding model. And it's supposed to be Claude 3.5 Sonnet. As you can see, 92.0%, zero shots for code. So let's just send it to Gemma 3N and see what happens. Let's not include in this image. Let's see if it understands that I'm talking about this particular image. Okay, it said 3.5 opus, which is not correct. It's supposed to be 3.5 sonnet. For some reason, it actually taking the name of the second column. That's got 3 opus is taking the subheading. Okay, appears to be the best coding model. And over here it says it has 92% zero shot, which basically is what it actually has. And I'm trying to understand how it actually got it so wrong. And here it's saying Claude 3. Okay, so let's update the prompt. This time it will be which model is the best coding model in this image. So we'll see if it's just going off its data set, like it's training data, or it's looking at the image directly. Let's send it again. So for our next test, we're going to be asking Gemma 3N what is the value of Gemini 1.5 Pro GPQA benchmark. So we'll see if it understands that this is dash and it's basically empty, and we will see if it can actually locate this particular cell in this table. Anyways, let's head back to the GUI. Okay, it said something similar, but this time it forgot to add sonnet when it actually answered. Previously, it actually said Claude 3.5 opus instead of Claude 3.5 sonnet. Here it just said Claude 3.5, and but one thing is that Claude 3 opus, it actually recognizes that that is also in the table, unlike the previous answer it gave. So that's kind of a success. I would say 75% pass. Let's move on to the next question. So the prompt here is simple. It says, what is Gemini 1.5 Pro's GPQA benchmark score in this table? So based on the image you sent, Gemini 1.5 Pro GPQA benchmark score is 85.9 with 5 short learning. That's really wrong. Very wrong. Anyways, let's head back to our IDE. As you can see, this is Gemini 1.5 Pro. It has no GPQA benchmark score. Instead, it actually took the MMLU score and it passed it on as the GPQX score. So that's a very big fail. Anyways, let's move on to the next test. And for our next test, we're going to be selecting Henry Cavill's image and we'll ask Gemma 3N, who is this? Because I want to know if they did leave celebrities' data and they also labeled it in their training data set. Because most times they just scrub it from their data set and the multimodal large language model can't recognize any celebrity at all. So that's something we would find out now. Okay, that's a pass. It actually got it correct. This is Henry Cavill. He's a very well-known actor, famous for his roles as Superman in the DC Extended Universe, Arthur Pendragon in The Witcher. No, he's not Arthur from The Witcher. I don't know where it actually got that from. Charles Brandon in Tudors, Clark Kent in Man of Steel. I would need to check this because he's supposed to be Geralt of Rivia. I'm not sure he answers Arthur Pendragon. Okay, anyways, he did a pretty decent job. It's got the name of the actor basically. That's what I was actually going for. So that's a pass. So for final test in image understanding, we're going to pass in the 6-fingered image. Let's upload that. We're going to use this one. How many fingers am I holding up? Let's see if it actually understand the image. You're holding up 4 fingers. The thumb is curled towards the palm. Very, very wrong. This is so wrong. Let's just ask it, how many fingers do you see? I see 5 fingers in the image, which is wrong. 6 fingers. 3, 3. Okay, that's a very big fail. So for our final test, let's head over to the video tab and we're going to be uploading a video and that video is going to go off to the cloud server, and at the end of the day, before it's actually passed on to the model, it breaks it down into a sequence of images, basically, into different frames, and then be passed on to Gemma 3N. So it's more like image understanding, but the only difference is it's not just one image, it's a sequence of images. And that's what we're passing to Gemma 3N. And from there, whatever prompt we pass over to the model, it's going to use that to give us a reasonable answer. Or let's say if we ask it to describe what's going on in the video, it's going to break it down for us. And something to take note of is I did limit the maximum amount of frames that will be sent to Gemma 3N. So while the full video is being sent to the fast API server, the complete number of frames from that video is not being sent to Gemma 3N, so as to save time. So let's just select the video. And for this test, I'm going to be using this video. It's basically a thriller from Mission Impossible. Okay, that's enough. Let's ask it to describe this video. Okay, it's done, and the response we got is this. The video showcases various action sequences from the movie Mission Impossible, Dead Reckoning, It's not part 1, it's part 2, but did a pretty decent job with the name. The clips include an aerial shot of a character in a red and white airplane, a dramatic shot of a vehicle with missiles being launched, accompanied by smoke explosions, a large explosion at what appears to be a significant building. Yeah, that's actually accurate. This is the airplane, and yeah, this is the explosion. It is really cool. The Mission Impossible logo, a series of scattered red and blue squares on a black background. So I don't know where I got this a series of scattered red and blue squares on a black background from. Anyways, it says the video is dynamic and highlights the high stakes action packed nature of the film. The scenes suggest espionage, high speed chases, explosions, and daring feats. Really cool. Not bad. It's not bad at all. Let's just ask you to describe this. Let's see if it will know that this is actually a video. Okay, it still did a pretty decent job. It said the image contains a series of short video clips from the movie Mission Impossible. Here's a brief description. Got same number of briefs. A yellow aircraft. Cool. So overall, these clips depict high action sequences involving stunts, explosion chases, and intense moments, characteristic of the Mission Impossible franchise, which is really cool. At least it actually recognizes that this is short video clip. So the only error is it said the provided image. Image in singular. So, but anyways, I won't fault it for that as long as it actually recognizes that this sequence of images are actually a video clip, which is really cool to see. And that's going to be it for our test, and I'm pretty much impressed by this model, even though it makes lots of mistakes when it comes to image understanding. Like you can actually give it different prompts and give it the same image to give you something very different. Even with the same prompts, it will still sometimes fail to understand what's going on. But the number of passes was really high. Like it actually did a pretty decent job when it comes to image understanding. And the really cool part is that it actually aced the audio test. Actually did a very decent job at audio understanding, which is really cool because it simplifies how we actually communicate with these models basically. And it's cool to see. You could just talk to the model directly instead of having a speech to text, transcribe, and then send it over to the model. It just streamlines the workflow. So that's really cool to see. And then for the video, it did a very decent job. It didn't actually fail the test. It did a pretty decent job. Let's say 80%. So honestly, the Gemma 3N model is really impressive. Like really impressive. Especially since this is just a 4 billion parameter model compared to what we could actually do with these models like a couple of months ago or a year ago. This is actually impressive. This is a major improvement basically, and it's cool to actually play with it. Anyways, that's gonna be it for this video. If you do like what you see, make sure you do subscribe, hit that bell notification to get notified when we release the next video on this channel, and do not forget to like, share, and thank you for watching. Have a nice one.